Okay. Hi, everybody. So my name is Kim Crease. I work in the Consumer and Community Research Group at the Federal Reserve Board. I'm going to be presenting some work today, joint with my co-author Mike Zabak, also in CCR at the Fed. And I'm going to be talking about some work that we've been doing to analyze open-ended responses from an annual survey that we do. So just a quick overview of how my talk's going to go. I'm going to spend a little bit of time talking about motivation and overview, and then spend the bulk of the time talking about the data in the sample and the methods and getting into the code. So standard disclaimer, the views expressed in this presentation are those of the authors and does not reflect the position of the Federal Reserve Board of Governors or its staff. Okay, so motivation and overview. So each year, the Federal Reserve conducts the survey of household economics and decision-making, called the SHED. This is a nationally representative survey, and it focuses on the financial lives and experiences of U.S. individuals and households. So we ask people a lot of questions. We ask them questions on a range of topics from economic well-being, financial fragility. So we get a lot of press coverage for a question where we ask people how they would cover an emergency $400 expense. So you might have seen that, that's us. We ask a lot of other questions about student loans, education, income, banking, housing, retirement. Okay, so most of our questions are multiple choice questions. We're a pretty long survey, but we each year ask one open-ended response question. Generally, this question changes each year. We're a pretty new survey. We're about 6 years old, so we have a little bit of leeway to kind of experiment with different types of questions and change our survey around a little bit. So in this year's survey, we first ask respondents a multiple choice question where we ask them to tell us how they're doing financially, and then we ask them a follow-up question to briefly explain why they selected that answer. So this is a snapshot from the Federal Reserve website of what the survey instrument looks like. So everyone will get this first question. Overall, which one of the following best describes how well you're managing financially these days? If I were to select that I was finding it difficult to get by, I would then get a follow-up question that says, in a sentence or two, please describe why you're finding it difficult to get by. So the kind of problem that we have with this is we have over 10,000 write-in responses to this question. We're a pretty small group. We're an annual survey, so it's costly for us to analyze these data. So I set out to explore with this project to kind of see what kind of tools and techniques we could use to try to systematically extract information from these write-in responses. We collect this information, it's really cool, you can check this out, we should be using it. So, and then I'm just going to talk a little bit about why this is important. So why we're asking this question, what we're thinking about when we're asking this question. So why this is important. So we have a lot of information on consumers' finances. So we have information about people's assets, liabilities, their spending patterns, but we have a lot less information on how consumers feel about their finances or how they're evaluating or understanding their financial situations. And the bottom line to this is consumer attitudes and beliefs drive decision-making, and decision-making obviously affects outcomes, and we are really interested in lots of different consumer outcomes at the Federal Reserve. Okay, so just from kind of a survey point of view, why this is important. So one kind of unique thing about this type of data is we might actually be able to identify some emerging trends or issues that just might not otherwise be captured in multiple choice data. So we give people the pen, so to speak here. We let them tell us how they're feeling instead of giving them a question and giving them 4 bins to put themselves in. We may also be able to see some cyclical patterns in what people are talking about. So this is an annual survey. If we ask this question each year, we might just be able to see some cyclical patterns that align with the business cycle or other things that are going on. We can use responses here as kind of a sanity check for the rest of our survey. So if it is the case that we're finding some type of emerging trend or issue, we have a really cool tool, this annual survey, that we can actually go in and make new modules or otherwise edit our questions to capture these. On the other hand, if we don't get any new information from these write-in responses, that's okay. That probably means we're doing a good job, and there's definitely lots of value in knowing that. And finally, this ties in a little bit to the first point, but we can collect information on what it means to be doing well or doing poorly financially, in the words of consumers. There's not really that many data that currently exists that does that. So this is a really kind of unique data set. So just a general type of research question that we're thinking about when we're analyzing these is what circumstances, life events, and attitudes are important for people when asked to describe why they view their financial well-being in a positive or negative light. Okay, so the data in the sample. So we have 11,316 respondents in this year's survey, and just about all of them answered the first question that I showed you, so how well they're doing financially. This is the distribution for US adults, the financial well-being distribution. So about 75% of people say that they're doing okay or living comfortably, which is pretty good news. Overall, people are doing okay. But we still have a non-trivial amount, so about 25% of people that tell us that they're either finding it difficult to get by or just getting by. So if there's any survey methodology folks in the room, we have a really high response rate for our follow-up open-ended question. In the past, we've asked our open-ended question as a standalone question, and usually about half of people answer. This year, we had over 90% of people answer, which is great. That also gives us a lot of write-in responses to analyze. So we have, our sample size ends up being 10,440 write-in responses. So they tend to be pretty short. The median word count is 9. The mean word count is 12. And I just kind of want to give a sense of what people say to this question. So I'm going to show some examples from the lowest category, which is finding it struggling to get by, and then the highest category, which is living comfortably. So in a sentence or two, please describe why you're struggling to get by. No work in rural community, my hospital bills, bad job prospects, student loans. I'm disabled and I make $831 a month, so I have to pick meds and food versus rent and bills. Single mother of 2, my job is not giving me enough hours. I've applied to different job openings and haven't heard back. And then on the other end of the spectrum is, in a sentence or two, please describe why you are living comfortably. Good job, no debt except for a mortgage, savings are growing, 2 experienced full-time wage earners, 2 good incomes, low credit card debt. We have retirement savings, don't worry about our finances, the house is paid for, we can pay off credit cards in full and travel when we want. And I retired with $1.8 million in investments and a fully paid for home. So we get a wide range of topics that come up across all the different categories, but how they're talked about really varies a lot. So even just from these 5 responses from each category I showed, you can see there's different talk about income. So people either have steady income or it's not predictable. Debt, not having debt is obviously very good. People are averse to certain types of debt. Credit card debt's not a good one. People are okay with having mortgage debt. Health was one that came up a lot in a lot of different contexts. So people talked a lot about disability. Also medical bills or having good health insurance was also talked about, and even having just good health was actually talked about as well. And then again, we saw work. So two incomes versus 1, or having a steady job. Yeah. Okay, so I want to talk about some of the methods we've used for this. So we have a lot of responses. We're a small group. Analyzing by hand is really time consuming. So what tools can we use to efficiently analyze these responses? So we've tried kind of a lot of things with this. So some basic text mining techniques, simple machine learning and regression models, and some natural language processing techniques such as topic modeling. Today I'm going to talk just about the machine learning and regression models that we've used, and I included some stuff in the appendix for what we've done for the 2 other stuff if you guys want to go look at that later. But yeah, I don't think I'll have time to get to that today. So so we have a pretty unique setup with our data. We have responses that are labeled with an outcome variable. So we get these responses, and then we create a category for whether or not they said that they were in the bottom categories, so not doing okay, or in the top 2 categories. You get a 1 if you are not doing okay, so doing poorly. And this setup is pretty unique and allows us to use some simple supervised machine learning algorithms and regression techniques to kind of extract some information from this. So in our analysis, we use text data in the responses as features, and the outcome was a binary doing okay or not doing okay. So we aren't really all that interested in prediction, so why are we using machine learning? Because certain machine learning algorithms can actually have some inference and can give some information about feature importance, which was why we thought this would be a good extension. So the two that I'm going to talk about today and that we used was random forest and a logistic regression with an L1 penalty or a lasso. Yeah, I'm going to just talk through the models really quick just to kind of show how we're thinking about them and how to understand them. So random forest, as I'm sure many people know, it's an ensemble method that aggregates predictions of many different algorithms to increase accuracy. Random forest in particular is an ensemble method of decision trees. So decision trees, if you're not familiar with them, you've probably used one at some point in your life. They're used for both classification and regression. And they're a flowchart with similar structure to a tree, where each node denotes a decision. So this is just kind of a simple example of a decision tree. So say you have a basket of fruit and you want to classify whether or not they're apples, oranges, or bananas. You might split the immediate sample. Is it round? If it's not round, it's a banana. If it is, ask if it's red. If yes, it's an apple. If no, it's an orange. Okay, so I'm going to talk a little bit about how a tree decides where to split, because that's kind of where the, I guess, information comes from for the feature importance. So you can choose from among several different decision criteria for deciding what to split. Decision trees will split on the subnode that makes the sample the most homogeneous. So we use a Gini impurity, and what that kind of looks like. So if you had 4 apples and 4 oranges, and you wanted to build a model that would predict whether the fruit is an apple or an orange, the split on the left-hand side, right-hand side, yeah, would be a bad split under Gini because you still have half apples and half oranges in your sample. This one would be a good split because you've been able to split to exactly 100% with both of your classes. Okay, so decision trees on their own, they can be unstable and can lead to overfitting. So the idea behind a random forest is to just average multiple decision trees to build a more robust model that's less susceptible to overfitting. So this is just what a random forest would look like. So we have several trees that each give a prediction, and then you aggregate all predictions. And then for reference, just how a random forest works. So for a random forest, the feature importance for each tree, it gives a weighted calculation for how much each split decreases the impurity. So if a split happens at the top when you have a lot of observations in your sample, that will be weighted higher than a split at the bottom, where you just have maybe a few left in your sample. This is averaged across all the trees, and the features with this highest value are considered the most important. And then logistic regression, so it's used for prediction when the outcome variable is binary. It's used to estimate the probability that a particular outcome will occur. In particular with L1 penalty or lasso, it imposes a penalty that will lead to 0 coefficients for some variables. And then generally features that are not shrunk towards 0 can be interpreted as the more important. Interpretations can be a little, interpretation of the coefficients can be a little tricky to interpret here. It's the expected change in the log odds of not doing okay in our model, but we're pretty much just thinking about it in terms of the signs in magnitude in relation to each other. So the positive coefficient with the higher magnitude means that the presence of that phrase is associated with higher probability of not doing okay. So I'm going to go through just some of the code and pre-processing of the data that we did, and then show some results for what the models gave. So I used NLTK to do some stemming of words. I also converted stuff to lowercase, removed punctuation, some basic stuff there. So this is how it would work. So everything is lowercase. Security becomes secure. Living becomes live. Yeah, so we do that for all the responses in the sample. And then we use scikit-learn to split the data into test and training sets, and use from scikit-learn also a random forest classifier. I chose 900 trees for this with a max depth of 100 each. I played around a little bit with that, but we're still kind of refining the model. Then we transformed the input data. It's in Word form, so I need to transform it into something that the model can handle. So a numeric representation. So we use count vectorizer and bag of words, and I use bigrams as the features here. Yeah. And then we can use the fit transform methods from scikit-learn and use our training and test data and train the random forest. So our classification report, accuracies, okay, recall's not really great, but still working around with that. Yeah, and then we can visualize what the most important features are. So you can see not enough is written as the most important feature, cost of, which often came before cost of living, able to go up. We have fixed income, don't make, disability comes up. Yeah, and then we did the same thing with the lasso, using scikit-learn and logistic regression with the L1 penalty. And when we train the model, we have a pretty similar accuracy report. Recalls similarly the same. Accuracy and our RSE AUC curve are similar. And then this visualization's a little bit different. So so this is predicting whether or not you're going to be saying that you're not doing okay. So the positive coefficients all the way to, I guess, the left-hand side are going to be things like disability, don't make, and then the very negative coefficients are predictors of, can be interpreted as if those are present, it has a higher probability of saying that they're in the higher two categories. So the first one there would be no debt, can pay, have good, etc. So just a comparison from each of these two models together. So the bold and highlighted ones were phrases that came up in both models. So you can compare this relative feature importance within this column. You can't really compare them across, so the lasso versus relative feature importance. But yeah, so these were a lot of things that came up. So not enough, having the ability to pay or able to pay, fixed income, disability came up a lot as well. So yeah, just a discussion of kind of the results from this and how this has guided our thinking about analyzing these. So disability in particular. So mentioning disability is really predictive of financial well-being, although there was a pretty low incidence of this overall. I think it was about 2 to 3% of the sample. If you combined disability and medical, and that was about 8 to 10% of the sample, I think. But people talked about disability in a lot of different ways. So people talked about being on disability and they didn't have enough to live on. People talked about waiting for disability benefits to come through. And people talked about either wanting to work and not being able to work because of disability, or some other kind of relationships with disability benefits and whether or not you can work, even if you want to or not. Health also came up a lot. So there seems to be a relationship between health and financial well-being. So people talked a lot about not being able to pay medical bills. Yeah, so medical bills, hospital bills, having to choose between prescription bills or medical or other types of bills for the month. On the other hand, people also mentioned good health as important when talking about having good financial well-being. So that came up in a couple contexts. So people would actually explicitly tell us that they had good health insurance and they're happy about that, or they would just tell us that they were in good health, and that was important for their financial well-being. So debt was another one that came up a lot as well. So probably unsurprisingly, is people value not having any debt, and people are actually generally really averse to debt. But there is also the kind of caveat that people seem to have aversions to certain types of debt more than others. People were kind of okay with having mortgage debt, which makes a lot of sense. Student loan debt, people didn't like. Also high credit card debt. came up in both categories. So people talked about either having high credit card debt or not having to assume credit card debt as an important predictor of financial well-being. And some issues and next steps that we're thinking about on this project. So this doesn't currently incorporate weights. So this is not a we can't make any nationally representative claims from this. I think that's okay because I think that people are telling us about their very individualized experiences, what they're experiencing in their lives, and I don't necessarily know how well that might even be representative. Another thing is frequency. How frequent are each of these across responses and across different categories? So as explained with the feature importance in the random forest, it's likely picking up words that are really common in one category and maybe not in the other. I still think that's important, but that could lead to just some pretty low incidence overall, like the disability is only about 2% of the sample. Thinking about some other models or techniques, or maybe adding some more features to our models. One nice thing we have with our survey is we have a bunch of demographic information about the respondents. So we can add some information about income, education, and that might help improve accuracy. And then some deeper dives on these topics. We also have lots of modules in SHED where we ask some questions about disability or how people are paying for certain health expenditures and how that's affecting their finances. So we might be able to kind of have a bit more of a guided deeper dive on these different topics. And just some final conclusions is this is just one of many ways to analyze text data, and we've tried a lot of different ways. So unfortunately, most techniques won't completely automate this analysis for us, but they can give us some information about how to think about our responses, and they can definitely give us some information about different questions we should be asking and guidance for how we should conduct our analysis. So our results suggest that some factors that are important for determining financial well-being, so disability and health, debt, income, and work. And if you have questions or comments, any feedback or suggestions for this work would be greatly appreciated. This is my email. There is code for this on my GitHub page and slides on my personal website. And yeah, some references and thanks.
Thank you, Kimberly. Are there any questions? Questions from the audience?
Thanks so much. It was really interesting. Did you have some overarching questions about like how is the survey doing? You thought you could get out of this? Do you have any comments on that?
Our survey's doing well. Yeah. I personally found the health and disability aspect of this. Yeah, I found the disability and health aspect of this to be really striking to me, and I thought it was important to kind of highlight that. But I mean, we do ask a lot of questions about that already, but I might inform maybe some more questions about that. But, yeah.
Did you find any answers that you would consider to be kind of non-informative, or like they would say, I don't know, or I don't want to answer, as opposed to something, or how do you interpret the 10% that chose not?
Yeah, so I did look a little bit for across the groups, especially who was more likely or less likely to answer. So by groups, I mean the financial well-being responses, so living comfortably, doing okay, etc. And people who are in the bottom two categories are the most likely to respond if they have something negative going on in their life. They want to tell government agencies about it. They were a little bit less likely to respond in the top two categories, but still. So I did some basic cleaning for responses that like didn't make sense, or like they weren't technically refused, but they were blank. So those came out. There were a lot of people who told us that they were doing well or like doing okay because they could pay their bills every month. There wasn't that much information there, but that's good to know. Yeah.
Would that specific example lead to classifying like some people kind of getting to 0 every month versus deeply positive?
Yeah, so I also compared how people rated themselves with this question and the $400 question we asked. So I feel like if you say you can't pay an emergency $400 expense, you're probably not doing well. And actually, for the most part, these seem to line up. So that was like kind of a sanity check. Yeah, I mean, sorry, the question again exactly was.
Does the text help you classify what could be subjective?
Yeah, I think generally, so it's a little bit fuzzier in the 2 middle categories, or even with people who say they're doing okay versus living comfortably. Yeah, I mean, one thing we wanted to look at was like kind of what I guess how to think about what it takes to make you go from one category to the next type of category. Yeah.
Any other questions? Okay, next up is Ian Thomas from RTI International, who will be presenting using Python, PostgreSQL, and R to analyze NIBRS data from the Crime Data Explorer.
Thank you. Let me see if I can pull this up. Okay, there we go. All right, thanks everybody. Again, my name's Ian Thomas. I'll be talking about really getting access to the NIBRS data. I want to start by thanking all my co-authors and my teammates, Dan Liao, Alex Harding, Alex Giarocco did a lot of this work, really reporting a lot of this, as well as some other teammates that aren't listed here. But there's been a team effort. So I want to start off with, and I also want to, I forgot to add the disclaimer in there, but I do want to add that disclaimer. This is all my personal understanding. I do not claim to speak for FBI or any other organizations involved that work with this data. But so let's start with, what do we know about crime in the United States? There is a program called the Uniform Crime Reporting, UCR, and that's been collecting administrative data from law enforcement agencies since 1929. And typically the big piece of data the big data set that they're collecting is the summary reporting system. So these are summary statistics that are voluntarily submitted, and they're counts. So they're very much how many crimes of this type occurred in your agency or your state in the past year. And given that, it's highly reported. So 99% of law enforcement agencies were reporting. Really good way to look at summary statistics. And there's some problems with it, with this data. One, it's summary statistics. You can't ask detailed questions. Another is that because of the way the guidelines are set up, you get hidden, some crimes are hidden from the results and aren't as prevalent. And so to solve these questions, or solve these issues, the government came up with the NIBRS, the National Incident-Based Reporting System. So this is a modern system, developed in the 1980s versus 1920s. It gives you incident level data and provides much more detail on each incident and allows for a broader range of crimes to be reported. And this gives you more segments of data specifically about the offense, the victim, and the offender. The only problem is that only about a third of law enforcement agencies are reporting as of 2018. Now, there's programs in effect right now that are aggressively trying to pull more people to respond, and so I expect that there'll be a lot more agencies coming online in the next few years. Quick show of hands, who's used the NIBRS data? Okay, great. So I will definitely continue to explain what's going on here. Traditionally, if you wanted to access NIBRS, you had two options. And both of those options were flat files. So you look online, you'll find them, and you have your choice. You can have any file as long as it's a flat statistical file. So it's or just straight ASCII if you're into that. And it's published in two different ways. One is the hierarchical file, and this is effectively just a straight spit out of the incidents. Problem is it's really large and it's really difficult to use. You're dealing with a lot of relationships in one giant flat file. So to fix it, they created the extract files. These break up the data into different segments and allow you to ask questions a bit easier as long as you're only talking about that specific segment. So if you're talking about offenses, you can talk about offenses all day long. You want to bring victims into it, that makes it much more difficult. Sometimes you just can't get there from here. But yeah, so these are both the way people have been accessing it. They're both generated from the FBI master file, FBI release master file. The only problem is that the last master file released was in 2016. So if you want to access 2017 data, remember there's a large data set, so it takes some time for things to get released. But if you want to access 2017, you're not going to find it in this format, and there's just no master file that's been released. But the thing is, you actually can get it, and that's pretty much why I'm here to talk to you today. Is the data is now the 2017 data for NIBRS is available on the crime data core. This is a FBI published website. I believe it's designed to be the new way that you access it. Access all the UCR data sets. You can get the master file from this page, 2016, but you can also get the 2017 data. And so this is where I look to find the latest and greatest. An interesting note about this is it seems to be updated periodically. So there no longer is this sense of this is the 2017 data. It's more, here's what's on the site today versus what was on there last week. And I think this is going to be updated kind of periodically as they see fit. But when you go to the site, you can pick a state and year pair combination and download a zip file. And what's in that zip file is effectively it's a relational database term text. So every table is represented by a CSV file. So you get all the data for that state and year for each table. You also get a convenient table diagram, so you can interpret this, as well as load and setup scripts for Postgres and SQLite. And so these are the key pieces. They tell you how to make it a database and how to load the data into it, which is great, except their use case that they built this for was one state, 1 year. And so if you're going for one state, 1 year, it's awesome. I'd recommend just using SQLite. You can run that on your desktop. It's a lot easier. But our use case is we want all the years, all the states, all the data all the time. So what we did is we wrote a Python program to download the files, so the deterministic URLs on the site. So we just ask for every state and every year. We don't get all of them back because not every state reports, but we don't care. We just ignore those and move on. We automatically extract all the files into a holding area, and then we set up the database, but we only do this once because database setup is just the structure. So we just take for one of the states, we set up the database for all of the rest. And then we load the files. And so this is a little snippet of our code. The big takeaway here is we use Python to execute the SQL that the FBI provides in this file. We want to make sure that we're as close to, that our database is as close to what was intended as humanly possible. So we thought one good way to do that would be to load the exact load script that we're given with the data. And we do this 50 times, at max 50 times per year of data that we have. And so this works almost perfectly. We log everything, look for errors. There's one issue with agencies. Sometimes agencies get put in twice, but the foreign keys explicitly state that you can only have one agency. So we remove the small amount of duplicates and move on with our lives. But yeah, so this gives us a huge database with, I think, roughly five and change million records per year. And we have in our database the 2016 and 2017. We found that 2015 and before is in a slightly different structure. So if you want to do longitudinal, you want to build one for 115 and before, and one database for 16 and after. The data is all really comparable, but there are some significant differences in the structure. So the way we recommend using it, or at least the way I like to use it, is using a piece of software called PgAdmin. It's a great piece of software for working with Postgres databases. It's an interactive SQL Explorer kind of tool. You might have seen these for other databases. MySQL, SQL Server have similar tools. But this allows you to click through the tables, look at the columns, look at the constraints, and most importantly, build and iterate your queries in an interactive tool. I highly recommend when dealing with databases with millions of data sets, you limit your queries while you're testing them. This turns things around a lot faster than otherwise. But typically the workflow here is we'll figure out what data we're trying to analyze on, create a query that generates a table that we're happy to work with. To do that, you have to understand the structure of the database. This is a abbreviated but very useful diagram that comes with the data. And here you can see how incidents can have multiple RSDs, offenders, victims, properties, and then you can see the different types of data that each of these segments are going to contain. Again, the simplified, there's a lot more details that you have to account for when working with the data, but this is a great way to get started. It's important to know that when you're writing SQL, especially if you're coming from an analyst workflow, it's important to know how SQL joins work. If you have a problem with your results, 9 times out of 10, it's with your join logic. Things I like to do is I make sure I always count my result set. I sanity check how many of something I'm getting. SQL joins can have a tendency to explode your result set or artificially reduce it. So it's always good to Google, look for a chart like this, think through logically exactly what's going on with your data set. And that is, a little pro tip for making sure if you find any bugs in your data results, joins are a great place to start. So once you've created your query, it's really straightforward to pull that query into R. We use a few different libraries, DBI, dplyr, and tidyverse. Those have all been really useful in helping us work with this data in R. You can see in the left-hand corner, lower corner, connecting to the database is pretty straightforward. We just put the database credentials in there. Database name, host, port, username, and password. I should have made that random. I didn't. Now you know my password. But once you have that connection, you simply just put that, use dbquery to add your connection and your query together, and that returns a data frame that then you can use to join your results. And so the biggest deal with this data set, with any really, but is to get specific indicators that you're looking to analyze. The joins and the queries you have to do are pretty specific. So let's see. So what we've been doing is going through, so there's some results. So we've been going through the data dictionary that NIBRS provides, as well as the NIBRS user manual, which defines to police officers how they should be classifying these results for their reports. really those two have been the big pieces, and we use those to create our definitions for what an indicator of interest needs to be, and then we'll write SQL code to pre-compute exactly kind of what we're looking for. So like, is on view arrest is the concept that we're trying to gather, where what that means is that arrest type equals 0 is what, so instead of having to do that cognitive load of like, if arrest type equals 0, then I know that on view arrest equals 1 every time I'm doing my analysis. We've been baking that into the SQL so that we think about it once, bake it into our set of views, and then go from there. So I'll skip past that last one, but what we've been using is a tool called DBT, which is a Python-based toolkit that lets us write these views and then keep that all in kind of Python and a templating language. We then save that off to, we then run that code, which then generates views on the database, which then materializes those views, making them a lot more accessible, and then giving us some nice documentation that lets us kind of see the lineage, of how things are created. So segment incident victim uses both segment victim and segment incident. And these get way more complicated, but it's a nice toolkit for keeping all of our results stored. We built that, and we also found that there wasn't quite enough for communicating to our analysts how to get there, or how to really use this tool as an analysis database. So we built a quick website that lets people just see our views, our analysis views, and then some simple data about what the rows they're going to be getting out of it, what SQL is used to generate it, and then a column reference that they can use to quickly pick out what's going on. So using this tool, they can kind of avoid that step of having to generate their SQL query, put that into R. They can just copy what we have here, put that in R, and then use this table as they see. So that's kind of where we're at now. This is all pretty much in development. Our next steps are to refine the workflow analysis, refine the analysis workflow, working with analysts to create more useful views and make sure that our analysis views are where they need to be. Ideally, we'd be creating views for all indicators, adding more automated quality assurance to all steps in the process, and then trying to make this faster by using a columnar database, and adding version history to the database, which would address the issue of these periodic releases coming out. But so that's all kind of internal work, but for you, key takeaways, if you're looking to work with NIBRS data and you want the latest and greatest, go to the Crime Data Explorer. Probably download the states and years you need. That's probably going to get you where you want to be fastest. You're going to need to use Postgres or SQLite. So if you're not familiar with databases, go befriend a programmer who is. That'll help you out a lot. And if you are going to use SQL, there's lots to know about SQL, but the two big things are use limits when you're iterating and join wisely. And again, remember that this data is going to get updated. So if you're going to publish on it, be mindful about how you report when you downloaded it, and if you need if you want to see updates, check the site again. And that's my slide. Ian Thomas, any questions? Thank you.
We only have about 15 minutes, so we're going to head into the fourth session. That's okay. And then we'll answer questions hopefully afterwards. So today's topic is weight calibration across packages, presented by Dr. Stanislav Kolenikov of ABT.
Thank you. Let me find my top share. Okay.
Click on that.
Thank you. Standard disclaimer, this is my opinion, not representing the company or any agency. So how many people do weights for living in this room? Anybody? Well, I do, so that was a big part of job description when I started. I moved on to some other stuff like small area estimation, data science, looking at things, but this is still an important part of my job. So typically, this is one of the weight creation and weight delivery and weight calibration is a part of creating a analytical data set from a population survey, like the Shed survey that Kimberly described. So typical components of weights include probabilities of selection, non-response adjustments, frame integration adjustments, and so on. And the step of weight calibration is usually the very final step. Once you've incorporated all of other stuff, you can say, well, my sample has breakdown that looks 60% female and 40% male, but I know that my population is 50-50. I want to do something with my weights so that they look more appropriate, more like the population of interest. I'm giving a vague reference to Devilas and their paper, 1992 just as a primary mathematical framework. So, how many people have heard of Stata? How many people have heard of that three-letter abbreviation? Someone to learn software? This is probably the only talk in the whole conference that's going to mention it. So enjoy what lasts. I'm going to compare several packages listed here. I'm going to skip some others that I kind of tried, but they may or may not really work out. Some of that. I don't have access to Sudan. I know that it has some terrific stuff. Don't have access to that. I don't expect people in general to have that. And so I'm comparing several packages in Stata. One package in R. I've seen others in R, and I may not be aware of all of them. And that's not exactly an issue, but that's kind of the feature of open source development. Is that, well, you can write your own code, and nobody's gonna know about it. If you push it to CRAN, then of course it's there and it's publicly visible and whatnot. But it may just sit there somewhere on your website, and nobody's gonna know about it except for your 5 PhD students that you work with. All that stuff is written by people with different backgrounds. So I consider myself a service statistician. So official Stata command was written essentially by computer scientists, roughly speaking. Nick Winter is a political scientist. Neil Pacific is an economist. Thomas Lamley is an academic statistician. So there's a great variety of people there. IPFR is written by transportation statisticians, and they don't refer to statistical stuff at all. Economists do not refer to statistical stuff either. So people reinvent the wheel. Some of them would refer to iterative proportional fitting as the name of the routine, but that was about it. They would refer to the paper from 1947 by, I should remember it, but I don't, which presented the algorithm but gave the wrong objective function that it was optimizing, and they would not have been aware of 92 paper that was published just 27 years ago. And I wrote one of those packages, but as a user, I kind of expect that other stuff that I try, well, first of all, it works, produces stuff that I can use. That's the very minimal kind of passing threshold, and that's actually threshold that's not every package passes very easily. I would like to see some output, and I would argue that Stata is a little better than R and Python in that regard, because I think Python and R kind of grew up from the Linux prompt that's text only, and Stata historically has been multicolored, and that's just nice to look at. Well, this session is about fast data, and I'll talk a little bit about speed. And well, how many people have never had to edit their code? Right, so you're gonna make mistakes. I want to see that what exactly I'm failing to do right when I interact with particular software. So for the particular running example, I'll take a look at CPS economic supplement March data, and I'm going to reweight Texas to look like California based on a number of demographic variables. And I picked this example because the sample sizes are somewhat kind of in between kind of political polling world, where you talked about 1,000, and nationwide household transportation surveys, where you have 100,000 of responses and probably millions of trips, origins and destinations, transportation zones, and whatnot. This is probably more of an overkill compared to typical surveys as to number of dimensions and number of categories. But well, I wanted to push things with those software a little. So several tests that I'm running, just default settings, just straight up what's going to come out. I, as a survey statistician, know that things get tricky when you have population control totals that are at different scales. Some I know exactly where things might break, and I see if they break where I expect them to. And then survey statisticians like to make their weights in a limited range because that reduces your standard errors down the line. It's has the justifications, it has its anti-justifications. And ranking is the process of iterative, basically a very iterative process where you adjust one margin at a time. So I listed those 8 margins. I'll adjust one margin at a time, and there's an analytical version of that that has an objective function that can be easily optimized. And linear calibration does exactly that. It's basically some sort of a version of OLS regression that you run on your data. It's supposed to be fast, and I'm going to see how fast it is. And finally, I make some intentional errors and see how my software responds. So kind of summary slide on how the different softwares performed on the different tasks. My stuff works okay. Well, I wrote it for my production, so I broke it 2,000 times, 5,000 times. I've seen all sorts of error messages. I've seen all sorts of weight problems. I've written fixes for all of those, so it works okay. But writing all of those checks takes a toll on performance, right? So doing rigorous parsing and doing all the checks that everything aligns, all categories align, and whatnot, that takes time. The stuff that works analytically, it has closed form solutions, works lightning fast compared to that. And SAS, well, you think about what you have to do in SAS and macros. It's a data step, it's a proc step, proc means, proc sort, proc this, proc that. You have to save a data set, load the data set. It's just inherently slow. That's the problem of SAS programs mount. So speed comparison isn't particularly favorable to it. So some of the softwares, some of the packages just failed, just refused to produce stuff. For instance, this survey weight package said that your population totals are on different scales. I refuse to produce anything. At least it's explicit in doing that. Other packages would try to do something, but they would fail. Some would fail with cryptic error messages. Some would say convergence not achieved. And as a user, I would like to see more specific guidance on that. Turned out that, so for Thomas Lamley Calibrate, I have these dots here. For the particular settings that I tried, it did not converge, but when I kind of relaxed them a little bit, it did converge. So it's not a particularly, it's not a specific issue with the package, but it's just in this particular numerical setup, it did not work out. While in other packages, it did work out. Another one is another thing that's how are those calibration totals passed to the package. So one really scary approach that those two packages, survey weight and S3 weight, have is to say, give me a list of variables and give me a list of numbers. I'll match them by order. Oh my God. Okay, I'm supplying 150 numbers here. what if I supply 149 variables? Where is the variable that I'm missing? Well, that's a human error, and that's something that probably as a designer of the software, I would expect user to make this as the very first error. You got very wrong answers, and you're gonna spend half a day trying to figure out which is the variable that you missed, something like that. So there's some magic name requirements that were the SAS macro imposes, that you have to name your variable in a specific way. And well, I mean, as long as it's documented, that's fine. But all other packages have a specific way of linking metadata in your survey data set with the population control tools that you give. So, so this is the output from my package. So it shows the iteration log. It says, well, something's going on, don't worry. Every 5 seconds or every half a second, you're going to see new iteration line, and you can expect, okay, sometimes something's going on here. So you may not see it here, but the diagnostics, it says, this is the worst fitting cell out of all of the adjustment cells that you gave me, and this is the target that you gave me. This is what I achieved. This is the amount of discrepancy. See if it hurts you. So this is saying how many weights were restricted when I was putting those restrictions. So you see this spike at 15,000. This is my value at which I was trimming. So my package does not do linear calibration, which is fast with streaming, and other packages do, and I don't know what kind of black magic they're using. And it is slow. Full disclosure, could make it terribly fast. And well, my approach was actually I would use survey estimation commands in Stata, take the results, and with minimal editing pass them on to my rating command. So that was my whole idea. That the step from one to another, I run survey totals on ACS data, and I can pass them on to my routine when I work with the data set that I'm working with. And as a survey weight producer, I store a lot of metadata as well about what was going on, how convergence was achieved, what the discrepancies are, and so on. So basically, all the stuff that's shown here is stored somewhere as a metadata. So this is official Stata survey calibrate. What I don't know if you can see this, but what I like about it is that you can explicitly say, for this category of sex, for category 1 of sex, the target is this. For the category 2 of sex, the target is that. And that is explicit, and it's far more difficult to make a mistake in this format. I'll show you how to make a mistake, but and unfortunately, survey calibrate. Well, actually, so what happens there is that if I have extra categories, extra stuff in the targets that I don't have in the data, survey calibrate is going to complain. But if it's the other way around, and it won't, if there are some values in the data that are not declared as control totals, then it's not going to complain. It even worries me. I don't know what it's going to be doing exactly in that situation. So no diagnostic output. They say, okay, well, here's the result is for you, and you can check whatever you want. Maybe that's okay. So survey weight by Nick Winter doesn't produce much output either. It says your variable reached maximum number of iterations. Well, probably you need to have more iterations to converge. It has a bulletproof way of matching variables and their control totals. Basically, instead you generate a variable that is the control total, so there's no way to miss that. And that's, well, kind of consumes a lot of storage, but probably that's not a very big issue. Also, survey weight does not provide trimming. So calibrate from the survey package by Thomas Lumley. Again, it does not produce any output. Just, well, just here's your result. You have a new design object. So if you're interested in weight specifically, you need to extract that with weights function. And of course, everybody is fan of seeing as.factor naming convention. And factors in R was one of the most confusing things to me, coming from Stata, where it's labeled integer, an integer number and a label. So most of government data set comes with specific rich metadata saying that white single race is 100, black single race is 200, and so on. And R just say, okay, I'll just renumber all of that. You don't know what you're doing, I'll do it for you. Thank you. So S factors are terrific. I found survey calibrate to be fragile, and I cannot always put a finger on what exactly it is having difficulties with, so I have to try different ways of doing that. As it does not provide internal diagnostics, it makes it more difficult to do that kind of stuff. One awesome functionality that it has is you can adjust weights at the high level. For instance, if you want to, if for whatever philosophical reasons you want to have everybody in your household to have the same weight, you can achieve that by specifying that weighting factors should be applied at the level of household and the level of the person. That's a very cool function. So rake and trim is a SAS macro. It's been operation for close to 20 years. I think I've seen the first version dated around 2000. It produces a reasonably nice Word document with distributions, like it says, before raking, after raking, show discrepancies and whatnot. You've seen the timing. I'm not going to repeat that. Another byproduct of this being SAS is that the output of every iteration has to be put into the log. Everything goes to the log. So log for this particular run of 10 iterations was, drum roll, 14 megabytes. Thank you. 14 megabytes to create one variable. So if you're paying for cloud storage and it's taking you, I don't know, 60 hours to produce your weights, and along the line you accumulate a lot, 4 gigabytes of logs, it may begin to bite your wallet. I know, but well, again, this is just the way SAS works. There's very little way of. I mean, you can probably send this to dev now, but then you will lose your diagnostics. You probably would be able to find somewhere in those 14 megabytes where non-convergent happened, but well, there's still more work than that. It has an interesting flexibility of target accuracy. You can say, I want to calibrate on gender so that it's exact, but I want to calibrate on education with a leeway of 1%, for instance. So you can specify that kind of stuff with it. It passes control totals by running proc survey means, and there's very minimal, as I said, you just need to make one magic name rename to have your targets ready, and that's really nice. So one thing that I discovered, and I've seen this before, is that weight trimming is not a valid methodology from statistical viewpoint. Every package has its own way of thinking how weights should be restricted. It's kind of bothersome. So the basic results without trimming, without trying to restrict the weights, they all were numerically identical. But once you start incorporating those additional adjustments and constraints, things begin to diverge between different sources. So on the y-axis is the output of survey calibrate. On the x-axis is the output of my raking program. They kind of agree that those are large weights, but they disagree on how exactly those large weights are to be treated. Okay, so kind of last step here is as I try to play full and see how we can specify things. So obviously for the programs that are sensitive to the order of variable names and numbers that go with them, it's a big issue. And so what if I have 100 variables or 100 numbers in my specification of the population numbers, but 101 in the data, or the other way around? So my code produces specific error that says, those are the categories that I see in the control totals. Those are the categories I find in the data. This is the mismatch. Those are the variables that I see in the population, but not in the sample. Those are the variables and labels that I see in the sample, but not in the population. Again, I've done this error enough times so that I went to my code and wrote that specific check to see what happened here. So I explained that survey calibration does one but not the other, and what it produces. It produces a result. What kind of result that is needs to be evaluated, let's put it this way. So other packages produce errors. So rake and trim SAS macro ran one iteration, stumbled upon something that it didn't like, and exited probably with an error in the log that you can find somewhere in those 14 megabytes of output. For some other errors, it again would run without producing an error message, and I'm not terribly comfortable with that kind of stuff. So that is about all that I have to say. So here's my contact information, and you can follow me on Twitter if you are there. Let me see if I have any other comments. Thank you.
Thank you, Dr. Kolanenko. We'll open the floor now. We have about 5-10 minutes just to take a few questions from both presenters, Mr. Thomas and Stanislaw. So, any questions for either one of them?
This is not an intellectual question or anything. Just I was just looking at your crime data explorer. And can you just give us an idea of what the overall data is looking like? If I just wanted one row with 2,000 variables, how many variables would it be, and how many instances in here?
Can you clarify one row?
Well, if you put a database in third normal form and have one column, right? But let's say you want to have every variable that exists. You just want to have one incident number, first column. This is a good way to start thinking about what you're doing, right? So how many pieces of information for an incident? Of course, maybe blank, some of them, and then how many incidents? That was just to understand what it all means.
Yeah, certainly. I can't give you specifics, but it's about 5 million incidents in 1 year. About 7,000 reporting agencies, different sizes. An incident's going to have offense, offenders, victim, property, and a few other tables that are associated. And each of those could be multiple, right? And each, so for one, if you just wanted to like make a really wide sparse column or sparse database with where one incident gets one row, and you have to be representing multiple offenses, multiple offenders, and then each of those segments are going to have quite a number of columns